Okay, everyone, proofs. Let's talk about segment proofs, shall we? The first segment proof that we're going to do is going to be a fill-in-the-blank 2-column proof. Basically, I take a two-column proof that's mostly filled out, and I fill everything else out with, just a bunch of property names and stuff like that. So, first things first, before we even get started, let's ignore this. I'm just gonna put my calculator here on top of it. We'll pretend it's not there, and we'll see what we're trying to figure out. Okay, what we're trying to figure out is C is the midpoint of AE, and C is also the midpoint of BD, and AE is the same as BD, and I need to prove that AC and CD, or DC, AC/DC, it's a band. I need to prove that these two are the same. So if these, basically what I'm probably going to end up doing, or what this proof is going to do to me, if these guys are the same, okay, if that is the same as that, okay, then I'm going to use the idea that the midpoint formula makes that AC equal to CE, and then also DC is equal to CB. Okay, now notice the different colors that I did. Since these two guys are equal, I'm going to do some clever substitution. So instead of making like AC equal to CE, I could just replace CD with CE, or something along those lines, where I'm just going to do clever substitution. And then there's my proof. So let's see what they did. Let's see how they did it. And I'm just going to fill in the blanks. Statement A is always going to be the given. The first thing on the left is always going to be the given. So we have a lot to write here for the given. So C is the midpoint, blah, blah, blah. And also AE is congruent to BD. I don't have a whole lot of space, that's why I'm being lazy. Please let me be lazy for once, please. All right. AC equals CE, AC equals CE, and BC equals CD by the definition of midpoint. Okay, it's the midpoint that makes those guys equal to each other. AE equals BD. Well, where do I get that from? I get that from my given. So because these guys are congruent, their measures are equal to each other. So that's the definition of congruence. All right, so what they're asking me to do here is use the segment addition postulate to make something. So I'm going to go from AE, because this is what I'm thinking. AE turns into that, and BD turns into that. But before I can do all that, I have to say what AE is. AE is when I take AC plus CE and add those together. Whenever you're being asked to use the segment addition postulate, you are going to take a whole segment is going to equal two of its own segments added together. Not only am I going to do that, but I'm also going to do BD equals, where's BD? BD is going to equal BC, and look at the way I'm writing it out. I know what's coming ahead. So I'm going to make BD equal to BC plus CD. Now, if I have AE, and if I have BD, and I know that they equal each other, I can replace the AE with AC plus CE, and BD with BC plus CD, and this is by using the substitution property, substitution, but I'm going to be specific, substitution of C and D. Okay, so I turned AE into AC plus CE, there it is, and I turn BD into BC plus CD, there it is. Now, since I also know from B, I can replace AC with CE, and that's what I'm doing. Better yet, I'm going to replace CE with AC. So this is, again, substitution of B and E. Now, I have to make it so that I have AC and AC equals CD and CD. So I have to make my way all the way down here. It tells me what I do is simplify. Normally I use the phrase combine like terms, but if I'm simplifying here, I'm going to take the fact that AC plus AC is 2 of them, and CD plus CD is 2 of them. Now it's asking me to use the division property. So if I divide both sides by 2, I get AC equals CD. And if the measures are equal to each other, then by the definition of congruence, I get segment AC is congruent to segment CD. Okay, that's a 2-column proof. Not fun. All right, let's talk about this scissors problem that we're going to start from scratch here. Let me redraw this picture. I got A, I've got B. Ooh, AB, I have 6 of those. R right in the middle. Haha. I have C, D. I had a bunch of those as a kid. What do I know? I know that if AR is congruent to CR, boop, boop, then I can say AR equals CR by definition of congruence. I also know that DR is congruent to BR, so by definition of congruence, I can say the same thing. And I need to show that this right here plus that right there is going to equal that guy right there plus that guy right there. Now, normally, I attach everything to one line. So let's do this. Let me see what I can do here. Okay. I have AB. I have AB, and I know AR plus RB equals AB. Now let's take a look at what I'm trying to prove. I have AR plus DR. Can I turn AR plus RB? Wait a minute. RB is the same as DR. So I really should have called this. Oh, wait, RB. I want to call it BR. My fault. It's the same thing. 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 So I have AR plus BR equals AB, but I don't want BR. I want DR. Well, what I do know is BR and DR are the same thing. So by definition of substitution, I could just replace that with AR plus DR equals AB. Now let me rewrite this equation again. Here's my one equation. So I did one thing with this equation. The second thing that I'm going to do with this equation is I do want another thing with BR, but I do know that AR is the same as CR. So I'm going to use substitution again by saying instead of AR, I have CR plus BR equals AB. So if you're wondering what I'm doing, I'm making a rough draft. My goal is to say this in the end. Well, I can't say it right away, but if I take the fact that AR plus BR is AB, and I change the BR to DR, and then rewrite it again, but change the AR to CR, I now have AR plus DR right there. I now have CR plus BR right there. And if they're both equal to AB, then by using the transitive property, I can say that AR plus DR equals CR plus BR. Okay, so that's kind of rough, but let's write it out. I have my statements. I have my reasons. My given, always start out with the given, is going to be AR is congruent to CR. Also, DR is congruent to BR. And that's my given. Because I'm giving blah is congruent to blah and blah is congruent to blah, that's what allows me to say that phrase right there. So 2 is going to be AR equals CR and DR equals BR. And that is the definition of congruence. Using this guy right here, I can say that AR plus BR equals AB. And that's the segment addition postulate. And I realized you couldn't see half of what I was doing. 30. 4 is AR plus DR equals AB, and also CR plus BR equals AB. And that's because I substituted 2 and 3. And from that, if AR plus DR equals AB and CR plus BR also equals AB, then AR plus DR equals CR plus BR, and that's the transitive property. Of congruence. All right, these guys are going to take work. Have fun.